Kia ora koutou katoa, it's Mrs. Goodson here, and this is the first video about rates of reaction, and it's for Level 1 Science. This first video is about particle and collision theory. So particle theory is the theory that all substances are made up of particles, atoms, ions, or molecules. So the atoms make up metals. If the atoms lose or gain electrons, they form ions. And they can join together to form ionic substances such as sodium chloride or magnesium sulfate. Or the atoms can join together to form molecules, for example, in water or carbon dioxide. Uh, Part of particle theory is that the particles are always vibrating or moving. Temperature affects the speed of the particles. That means that when the temperature increases, the speed of the particle also increases. So in this diagram, we have a picture of a solid where the particles are packed closely together, a liquid where the particles are moving past each other and they're a bit further apart. So the more energy the particles have, the faster they're moving and the further apart from each other they are. So if they gain enough energy, then they'll completely separate from each other, and this means that the particles are a gas. These different states of matter relate to the different configurations of the particles. So we've got a solid, liquid, gas. So as we add energy to the particles, if they gain enough energy, then they'll melt and form a liquid. There's a liquid here, and if these particles gain enough energy, then we get evaporation or boiling, and they become a gas. But if we can take the energy out, start to cool it down, then we start to go this way, and that's called condensation, going from a gas to a liquid, and also from a liquid to a solid. The particles are losing energy to the surroundings and um, uh, becoming a solid, and we call that freezing, or another word for that is solidification. So in this direction here, we are adding energy. A chemical reaction, as opposed to a physical change, which we were just looking at, is when you have reactants and products. And the big difference between a physical change and a chemical change is that you are making something new. So they generate one or more products, which usually have properties different from the reactants. This involves the rearrangement of the molecular or ionic structure of a substance. In a chemical reaction, reactants contact each other, bonds between atoms in the reactants are broken, and atoms rearrange and form new bonds to make the products. So in a chemical reaction, it involves the making and breaking of chemical bonds. So the atoms get rearranged. Reactions can happen between solids and liquids, solids and gases. In solution, this is really important, especially for biological kind of reactions. Um, Liquids and gases with other liquids and gases, but not between, or very rarely between solids and solids, because the particles are fixed in place. So this is an example of a chemical reaction. We can write it as a word equation with sodium hydroxide plus hydrochloric acid. So we've got a base and an acid. These are kind of opposites to each other. So the reactor form neutral, sodium chloride plus water. So if we write this as a symbol equation. So we've got sodium hydroxide, hydrochloric acid, reacts to form sodium chloride and water. Now, I just wanted to break those ionic substances down, because when we have sodium hydroxide, usually we have it dissolved in water. So the ions are actually separated. So we've got sodium ions and hydroxide ions, hydrogen ions, and chloride ions. So these are all together. So we've got them dissolved in a solution in our beaker that was with a whole lot of water. Now this particles here, when they collide, they form water molecules. Okay, so that's where we get our water molecules from. The sodium ions and the chloride ions just stay in solution, and in fact they are spectator ions. So we could evaporate off the water and we would be left with solid sodium chloride. So this reaction is an acid-base reaction, forms a salt plus water, and we need to have the reactant particles collide to form the products. But the collisions do not always result in a chemical change. If the reactant particles are moving too slowly, they will just bounce off each other and there'll be no reaction. If the particles are facing the wrong way, then there will also be no reaction. So, to have a successful chemical reaction, the reactant particles have to have enough energy and be orientated correctly. New products will be formed in a chemical reaction only if the reacting particles collide with enough energy and at the correct orientation. Okay, and this enough energy is called our activation energy. So a solid substance will not usually react with another solid because its particles are locked into fixed positions and are therefore not able to move and collide with each other. A solid substance will react with gases, liquids, and aqueous solutions. That means solutions of water, because once reacted, more atoms in the solid get exposed to react also. So, in summary, we can explain chemical reactions by thinking about particles. Particles in a gas or a liquid or in an aqueous solution are constantly moving from place to place and colliding with each other. These particles can be atoms, ions, or molecules. Most chemical reactions occur by the collision of reacting particles, but not all collisions are effective in forming new products. New products will be formed in a chemical reaction only if the reacting particles collide with enough energy and at the correct orientation. So, this is the definition you need to remember. In order for a chemical reaction to occur, two or more particles must collide with sufficient energy and in the correct orientation. To increase the rate of reaction, you need to increase the frequency of collisions. Another way of putting that is collisions per second. And activation energy is the minimum amount of energy that a collision needs for a reaction to occur. So, this video has been about learning the definitions of particle theory, collision theory, and activation energy, describing state changes from, e.g., from solid to liquid in terms of particles and energy, and then explaining why collisions of reactant particles do not always result in a chemical change, and starting to apply knowledge of particles and collisions to explain chemical reactions.